So today we're going to start our new session, new book um, called Machine Learning with Pytorch and Sklearn. Um, so this is going to be something new that we haven't seen, that is Pytorch. And this book is meant for people that basically um, want to learn deep learning and also machine learning. Um, we are going to use Python, PyTorch, and Scikit-learn. So the book divided into two sections. As we all know that deep learning is somehow kind of advanced machine learning. So chapter 1 through chapter 10 works on machine learning. And chapter 11, 10, 11, 11 to 8, 19 works through deep learning. So chapter 1 to 10, they will be using Scikit-learn, which we have already seen in our previous sessions. And in chapter 11 to 12, 19, we will be seeing what is called Pytorch. Pytorch is a framework that is used for deep learning, such as TensorFlow. You may know TensorFlow, but PyTorch is now being used in research and for students. Is one of the widely used framework. So yeah, and this is a good book. I already shared with the book with you. Now, today what we'll see is chapter 1. And chapter 1 will be basically seeing something that we have already seen, we already know about PyTorch, about machine learning. This is just a recap of what we know. So it's not something big deal. You already know that. So let's start going on. So you can see the chapter basically introduces the concept of machine learning and the types of machine learning and the building block for successfully designing machine learning system. So when they say building block for successfully designed machine learning system, so for example, if you want to develop a machine learning pipeline or something like that, it describes that full block of pipeline. So building intelligent machine to transform data into knowledge. Machine learning, as we know, is basically ability to learn without to being explicitly being coded with hard rule. And there are many applications of machine learning, as you know, in many fields. The book give an example here, where researchers design system for predicting the oxygen need of COVID-19 patient to 4 days. So you can see this is some kind of prediction task, which is basically machine learning applications. We can see there are many stuff. We know email spam, search engine, recommender system. All of these are example of what machine learning can do. So now we know one of the main aim of machine learning is just to do prediction. For example, to predict future or to predict something. But also there are three different kinds of machine learning. Here we have supervised machine learning, we have unsupervised machine learning, and we have what is called reinforcement learning. So we have three categories of machine learning: supervised learning, unsupervised learning, reinforcement learning. So we'll see each one of these categories: supervised, unsupervised, and reinforcement learning. Now the subsequent chapters will take each one and see how it works. So let's look at the supervised learning. So supervised learning is a kind of learning that allow us to make prediction given some sample. So for example here, we have training data, we have levels. So what this means level is that, for example, I want to make prediction on tweet, given any tweet I see. I want to predict whether that tweet is positive, the sentiment toward that tweet is positive or negative or neutral. So for me to do such kind of prediction, I need to have a data set first leveled. So maybe I need to have a data set, 1,000 data set or 2,000, and this data set is labeled as positive, negative, neutral into different classes. So the data set is leveled into different classes. Now I can use that data set now to train a model that can predict any new tweets, which is not level. This is called supervised learning. So you can see the main goal in supervised learning is to learn a model from leveled training data that allow us to make prediction about unseen future. So this is what we call supervised learning. So why it's called supervised? Because the data you train, it is supervised. It has a tweet and it has the answer. This is tweet negative. I hate this one negative. I love this positive. So all the tweet annotated are level. So this is called supervised learning. We already know this. And now you can see training data with it is all level. And now you can feed into the machine learning algorithm. And now the machine learning algorithm can make prediction. And when you have new level data, you can make predictive model. So this is what is called supervised learning. And this is a lot of machine learning applications falls into this category of supervised learning. Supervised learning divided into two different categories. There is what is called classification, and there is what is called regression. So classification basically is a task of giving some data points to classify something. So just an example I gave for given tweets with three classes, positive, negative, neutral. So you can train a machine learning model to classify this tweet, whether something is positive or neutral. So this is what we call classification problem. So you can see it's a subcategory of supervised learning where the goal is to predict the categorical class level of new instance or data point based on the past observation. So you can see this is basically we want to predict category level based on fast information. So this is what we call classification, as we already know, and then regression for predicting continuous outcomes. So we have what is also called regression. So if you look at this, the regression task is basically trying to make prediction based on not categorical values. So for example, here we can see the prediction we made is to divide something into classes, maybe positive, negative. But in regression, it's just we are trying to predict continuous outcomes. For example, if you want to predict the price of houses, we can use regression. So that is what is called regression. So the main idea here is that under supervised learning, we have two tasks involved: classification and regression. Classification is to make prediction on categorical outcome, while regression is make prediction based on continuous outcome. So yeah, in machine learning, predictor variable are commonly called futures and response variable. So these are something that we'll talk about later. Yeah, anyone with question? Anyone with question? Okay. So that is supervised learning. What about unsupervised learning? So unsupervised learning is a kind of learning which basically so you can see here with supervised learning, you will be given with training data set that is annotated with maybe positive, negative. That is supervised. But in unsupervised learning, your data set is not annotated with any target. So in unsupervised learning, we know the right answer in unsupervised level before when we train a model. But in unsupervised learning, we are dealing with all level data or data with unknown structure. So in unsupervised learning, you will be given a data with which is not leveled, like that is it does not have a level, and you want to learn from it. So unsupervised learning techniques, we are able to explore the structure of our data and extract meaningful information. So one of the example of unsupervised learning is what we call clustering. Clustering, for example, given some tweets, given a tweets that are not leveled, then we can we can maybe try to cluster these levels based on some kind of structure. For example, we can say cluster the levels based on the location, geographic location, or cluster the tweets based on the language in the tweet. So clustering is one of the example of unsupervised learning, that is to cluster some stuff. Yes. Any question? Falalu, do you want to add something?
No, Doctor.
Okay. We are all familiar with this. In our previous session, you can see we all know this, but some people, some of us here might be might join us for the first session. So that's why we recap this. So this is chapter 1. We consider we already know everything. Some of us. So feel free to see that you already know this. So we have another one which is called reinforcement learning. So now we have seen the first one, which is supervised learning. It uses a level data, and now direct feedback predict the outcome or future. What we mean by direct feedback is that you can see you have a feedback whether you have made a correct prediction or not, because you know that the levels you have are positive, negative, and now you can measure. But in unsupervised, have many direct feedback, and now no levels or target, and find hidden structure. So what we do, if you look at it in supervised learning, you make prediction of the future. You predict something that you don't know. But unsupervised learning naturally is not like making prediction, but what it's doing is finding hidden structure. That is unsupervised. It finds hidden structure. So given example I gave, given tweet, classify them into predict whether a tweet is hate or not. That is unsupervised learning. It's prediction, but it's supervised learning. I mean, but in unsupervised learning, naturally, what we are doing is not basically, in some sense, we are doing prediction, but we are doing what is called finding hidden structure. So this is what I give an example. Given bunch of document, for example, given bunch of document, so classify these documents into languages. For example, so a document is written in Portuguese, another document written in Hausa, another document written in English. So now, given all these documents, classify this document into different classes. You can see you don't have prior information whether you will not give the model whether this is Portuguese, whether this is English. No, you just give the model all the text and ask the model to classify this. So this is, you can see, is finding hidden structure. This is what we call unsupervised learning. Another one is which is also called reinforcement learning. So reinforcement learning basically is a kind of I have not finished with this. So reinforcement learning is basically a kind of machine learning that basically use some kind of agent and state and environment that actually change the environment based on rewards. We'll see the detail of this. For now, let's skip it. This is still on unsupervised learning, which I made mention is finding subgroup with clustering. So I already mentioned this. Another thing with unsupervised learning, let me take this one, is supposed not be here. Another application on unsupervised learning is what we call dimensionality reduction. So what is dimensionality reduction? So sometimes you see that you may have a data, and the data set may have quite large number of features, and such kind of features may present some challenges to doing machine learning. Now, one way to remove some features that are not really relevant to a task of machine learning, or they are not actually improving the performance of is what we call dimensionality reduction. That is, if you have, for example, features, 50,000 features, or let me say 50 features, then you can do dimensionality reduction to reduce the features from the algorithms and now leave only features that are meaningful that can contribute to the prediction. So dimensionality reduction compress the data onto smaller dimensions while retaining most relevant information. So this is also part of unsupervised learning. Yeah, so this is also part of what we call unsupervised learning. So to recap, we have now seen two different kind of things. Number one, supervised learning, which we are given the level data and we make a prediction. The second one is unsupervised learning, You will not be given the levels, and what you need to do is find hidden structure. And we said that in supervised learning, what we have two kind of tasks: classification, and we have where you will be given a data set you try to classify, and regression, where you can predict continuous variable, continuous value. And for unsupervised learning, we discuss one of the main tasks from unsupervised learning is clustering. So given some bunch of information, try to cluster them. So you can see this is not prediction, but trying to do some clustering. Another thing that we can work with on supervised learning is what we call dimensionality reduction. So given large amount of data with many noise in it, how can you remove noise data that will not actually improve the performance of machine learning algorithms? Then you can apply unsupervised learning, which is dimensionality reduction approach to do that. So we have now seen two examples in each one, but unsupervised learning also can be used to actually for visualization. So you can see here we have we have an image here in 3D, right? So unsupervised learning can be used to visualize data, to project the data from higher dimension into lower dimension. So you can see here, we may not see the real picture image here, but you can project this higher dimension to lower dimension. You can see we have 2 dimension here. So this is also an application of unsupervised learning. We'll see the details of this. Today is just introduction on what kind of tasks we have, the chapter 1. But we'll see how we can do all this stuff in subsequent chapters. So just today is trying to show us what different kind of stuff we'll see in the subsequent lessons. So now unsupervised learning, you can see, is also used for image for visualizing images. Now let's introduce some terminology to be used for machine learning, which we already know. So for some of us that we are here in our previous session, we already see this is a good example that we have been seeing. Right. So if you want to do machine learning, how can the data be given to you? So the data is given to you in form of rows and columns, right? In form of rows and columns. So this is, for example, row number 1 to number 50, 150. Now, these are some of example. So this row, a single row, is what we call instance or observation. So we have 1 instance, 2 instance, up to 150 instance. These samples, all of them is called samples, and each one is called instance or observation. So this is instance, this is instance, this is instance. Now, this is what we call features in machine learning. It's called features. So here we have features. They are also called at input. They are also called attribute measurement dimension in machine learning. But if you look at this one here, what it's saying is that we have a flower here. You can see this is a flower. And now this flower has what is called petal, has what is called sepal here. This is sepal. And it has what is called length and width of the petal. So you can see here is the length. This is the width of the sepal. This is the length. This is the width of the sepal. Now, the main idea here is that we want to predict if a flower. So the people now, they want to do machine learning, they find many flowers, like 1,000 flowers, I don't know. When they find many flowers, what they do is that they measure the petal width and petal length. Measure the petal length and petal width. Now, what they find out is that this is sepal length, this is sepal width, this is petal length, this is a petal width. Now, when they have this, then when they find this particular width, then that flower is setosa. They measure another flower. This is the sepal width length. This is the sepal width. This is it. Then with this, this is setosa. So you can see here the petal width for setosa is 0.2. 0.2 is meaning that it's somehow low and small number. But look at the petal width for Basilicula flower is 1.2. Look at the petal width of Virginica flower is 1. So these are some of what we call some point measurement that can be used to classify our flower. So this is all information about one flower. That kind of information is what we call an instant or observation. And this is the what we call class level. So when we are doing machine learning, you will be given this section. Can you see the that is the information, these features. And now you'll be given class level. And the class level is okay. Machine learning will learn if this sepal length, sepal width, petal length, width. This is a two side. This is so the machine learning model. You will give machine learning model maybe 100 of this data set, 1,000 sample, and now he will learn from these examples. Now, whenever you give him something that is not within this example, the machine learning will try to predict the correct class. So this is basically what we should know, the structure of machine learning data, how the machine learn data. Any question before we continue? Zaradin, can you add something? Okay, anyone was question? Yeah, so as I said, some of us that are here for our previous book, we already know some information, but we are working through for some of us that are not here. So this is basically some of the terminologies you will see be hearing in machine learning. Samples, everything here, futures from here to here is a futures of measurement of your machine learning. But from here, that is called class level. And this class level is sometimes called targets or outcomes. Target, whenever you see target or outcome, it means this class level. That is given some futures, what is the class? Or what is the target or outcome? Given some futures, what is the target or outcomes? Given some future, what is the target? So these are some of the terminologies we should put in our mind. You will see them, people use them differently so that you know what they mean. Right. These are some of the explanation of this training example. So this is, for example, training example. We also have what is called training example and testing. So if you want to do the machine learning, you will be given training example, dividing the data into two training example and tested, and you will see that. Okay, then let's look at the roadmap of building machine learning system. So what is the roadmap here? Now, the roadmap here is that when you want to do machine learning, the first thing you will do is basically to collect your data set. What do you mean by this? So you can see this is raw data collection. So for example, you want to collect data from YouTube comments. Yes, you want to do some kind of analysis, or you want to collect data from Facebook comments, or you want to collect data from Twitter comment. So this is where when you put all this data, you get the data, you will have a data set. That is pipeline. We have what we call pre-processing. Before you train your data to machine learning model, you need to do what is called pre-processing. For example, if I'm using data set from Twitter, I need to remove, for example, hashtag. I need to remove emojis. I need to remove a lot of other stuff. We will see all of them. But here, just telling you the big picture, how we will be doing machine learning. This is just the big picture. Now, when you have your data set, you will not just start training the model. You will divide the data set into training set and test set. So this is, you have your training set and you have your test set, right? Now, when you have your training set, what you need to do is process the training set. You do a lot of pre-processing, for example, future scaling, dimensionality regression, hyperparameter choice, and training. From here, okay, this is this step. But before you do give to your machine learning algorithm this step, you can do this. That is pipeline number 2. When you finish pre-processing your data and your data set is ready, what you need to do is to select machine learning algorithm that you will do. And now you select the machine learning algorithm, but we have tons of machine learning algorithm. We have support vector machine, we have decision tree, we have SBM, many things. So there are a lot of stuff. How can I select which one is best? So we'll see how that works. So you have this, and now you can make prediction. When you make prediction, now you need to select the best algorithm. So in essence, sometimes you need to train your machine learning algorithm with maybe 10 of algorithms, and you select which one has a best accuracy. Now, when you have one with best accuracy, now you can test that model with your test data, which you use final processing, and now you apply on new test data. So this is basically a rough structure that will be seen in this section, in this book. From the beginning of this to the end, we'll take each step and see how it works. So this just gives us a rough idea what we'll see in the next chapters. Any question before we continue? Okay. So yeah, so this gives us the basic idea what we see. So pre-processing, getting data into shape. We already know that data may not come pre-made in a good shape. We need to do some kind of pre-processing. Thus, the pre-processing of data is one of the most crucial steps in any machine learning. So sometimes you can see people say pre-processing, putting your data in good shape for a data science take like 80% of the time, or 70. 80, they say. You can see that if you go the data set, getting your data to train the machine learning model is the heart of machine learning model, getting the data. So if you have 1,000 hours to do machine learning model, to spend 70 hours getting a good data set, because when you don't have a good data set, then you will not have a good machine learning algorithm. So getting machine learning algorithm is easy, but getting the data is the difficult part, and putting the data in a good shape. So whenever you want to do machine learning, spend at least 78, 60% getting the right data. Getting the right data is the first thing you need to do. So that's that. So there are many kind of pre-processing that we do in machine learning, and this kind of pre-processing, we will see them, for example. But here, we'll see them in the details. You can see here, we are not coding, we are not doing any machine learning. Just this is introductory chapter, but here they talk about some of the pre-processing steps. So one of the pre-processing is that you need to change your data set into some kind of distribution that is 0 and 1. We'll discuss this in detail as well. We can do also dimensionality reduction, which I made mention previously. For example, if you want to do machine learning and you have your features, they are like 1,000. So this example I gave here. So for example, if you have machine learning, you want to train machine learning, and this feature, you can see here how many features do we have. We have 1, 2, 3, 4. We have 4 features. You can train your machine learning model with 4 features. But what about in the case where you get a data set with like 60 features, 70 features, 80 features? And it turns out that these features, they may not really be indicative, predictive, may not have a predictive performance capacity. Then you can just remove them. But how do you know which feature to remove? That is what we call dimensionality reduction. That is when you can use unsupervised learning. It will remove features that are not doesn't have predictive capacity automatically, without you having to know like which one should I remove. So unsupervised learning will remove features that are not actually really well for your stuff. So yeah, so in certain cases, dimensionality can also improve the predictive performance. You can see when you do dimensionality reduction, you can increase predictive performance of the data. We also do need to do what is called testing. So when you train your model, you don't expect your model to work from the beginning. For here, I train my model, I now have predictive performance. But when you train the model on a training data set, you cannot truly tell that is a good predictive performance unless you test the performance on test data. Remember, when you have a full data set, you take some part. For example, here I have 1,000. Then you can take like 20% to be test set. Now you train your model on 80%. When you finish training the model, you tested 5 machine learning algorithms, and you see that, oh, support vector machine has better performance. Then you can take that support vector machine and now try to see the performance on test set, because you have not trained the data train on test set and see, yeah, okay, this is what we call evaluation. Because the the machine learning algorithm have not seen the test data, then you can do evaluation on that. So that's what we mean by that. Now, this said about training and selecting a predictive model. Now, how can we select a machine learning algorithm that work best? As I said here, we need to try many machine learning algorithms and select which one is the best one. But it turns out that there is no what is called free lunch theory. So the goal of training a machine learning algorithm is to learn a model that can predict the outcome of new data. But no single algorithm or no single model works well on all types of data. So someone may say, oh, you need to use support vector machine. Someone may use linear regression. Someone may say you need to use decision tree. But the problem is that not every algorithm work on this different kind of data. If you have a problem, maybe I'm doing sentiment analysis, the mismatch, the algorithm that work with that may not works well when you are predicting maybe house prices. So it turns out that we should know which algorithm work best on our training data set, on our kind of data set. So yeah, so the main idea is this. It is essential to compare at least a handful of different learning algorithms in order to train and select the best performance. So since not every algorithm works based on each and every data set, what you need to do is maybe you can select 5 algorithms, 6 algorithms, 10 algorithms, and try to see them which one works best. Then you can select the best one. Yeah, so we also have what you call about parameters. So you can see here, we have what we call a hyperparameter choice and training. So all these machine learning algorithms, they have what is called hyperparameter. We'll see what hyperparameter meaning. Meaning, when a machine learning model make prediction, you can fine tune it, you can tune it, meaning you can touch it to make better predictions. So there are a lot of other stuff that makes your predictive capacity of the model to improve. That is changing all this kind of stuff is what we call hyperparameter tuning. So we see that also how you can improve the performance of your machine learning algorithm by changing the hyperparameters so that it increases performance. Yeah, so that is what we have here. You can see all models are wrong, but some are useful. Meaning what this is telling you is that not every model works well on every problem, but some will work. So the idea is trying to say is that just try many models and select the one that works on your data set. Okay, then finally evaluating your model. So you can see here at the end of the day, when you make prediction, we need to evaluate the model, right? To evaluate the model is to try to select the best model. So you try 10 models and you see one model works best. Then you take that one model and evaluate it on test data. So that is the last step of machine learning, evaluating model. After we have selected a model that has been pitted on the trained data set, we can use the test data set to estimate how well it performs on these unseen data to estimate what we call generalization. So always what we want is that we want a machine learning model that will generalize on test data. So what do we mean by generalization? Now you get your data set, you divide the data set into training set and test set, and now you do pre-processing, select 10 algorithms, and now make prediction on that training data. So you among those 10 algorithms, you see one works best. But that works best on training data. During training, it sees the data. But we want algorithm to work best on data set that have not been seen during training. That is what we call generalization. Performance of a model on unseen data set. That is, you can see test data has not been seen during training, right? The reason why we divide this is that the model, why train the model sees his training data set. So maybe he can cram or remember all this data. So it means that the model memorized the data set. So you want to test the model on new tests. For example, you want to do exams to your student that you are teaching, and you teach them 1 plus 1. So they know is 2. You teach them 3 plus 1 is 4. Now, while teaching, if you want to test them to see they really understand, I bet you will not give them 1 plus 1, right? You will not then give them 3 plus 1, 4, because you teach them in the class, you tell them when you want to evaluate their performance, you give them something different. So you can give them 5 plus 1, right? So this is the same idea, test data. So you cannot know that your machine learning algorithm works well on training data. You can really know your machine learning algorithm learns, generalize. When I say it learns very well, it generalizes on test data. So this is some keyword that is being used or terminology. When people say that your machine learning model generalize, it means it works it works well on test data. So that is what we mean. After we have selected a model that has been pitted on the training data set, we can use the test data set to estimate how well it performs on this unseen data. If we are satisfied with its performance, we can now use this model to predict new feature data. So now the idea is this: if your model now works on test data, then you are okay. If it works, then it's okay. Then you can tell the model to prediction. If you want to put it in your mobile phone, if you want to it in web, wherever, if you want to take it for prediction, now you can just put it in prediction. And now any data set that comes, new data set that is not part of data set of training, the model will be able to classify it. Now let me give you an example. I get some data set, annotated and train machine learning model, Twitter data set. I train machine learning model, and now I test. I select the best performing algorithm and now test it, and the model works. Now, what is the essence now? Is now to take, if I want to detect hate speech in Twitter, now I will take this model that works well on test data, and now I go and plug it into my my application, a web application, that model. And now when people are tweeting in Nigeria, that model will be able to detect. You can see that this is new data set. It has not been part of training data set. It has not been part of data. This is real data sets from around the world. So when people are detecting tweeting data set, they are tweeting some stuff. Anybody that tweets something which is hateful, my machine learning algorithm will try to classify it as hateful. So this is what it means. All the life cycle of machine learning. Train your machine learning, test it. If everything works, now take it to production. So that it will detect, it will be applied on real life scenario. Yeah, so it is important to know that the performance of previously mentioned procedures such as feature scaling and dimensional regression are certainly obtained from different data sets. So this is something we will see while we are working, that is dimensionality reduction and some of future extraction. We'll see that in detail. Yes, anyone with question before we continue? Okay, yeah, I know this is something we already know. So we'll start seeing something new when we start working. Using so this is something so all of us the chapter discussed something here finally, how you can install the Python packages. So I guess when you download the book actually, I think okay. All right. So how can you start using this book? For example, you yourself. So if you look at this one here, what they are talking about is how we can install Python packages. We all know how we can install Python package, right? We use pip install some package or pip install if we want to upgrade, pip install upgrade. Now, for example, for anyone want to install Sklearn, I mean some stuff, some packages, we already know this. I don't need to do that, but there are a couple of ways we already know that is what we call Conda. Conda is quite useful for package management. So that is what is called Anaconda. That is what is called Mini Conda. That is what is called Mini Forge. So you can see there are three things. Anaconda is something that you can download from Anaconda website. And when you install Anaconda, then Conda is available for you to do installation. But Anaconda download everything. Then something that people may not want to download everything, you can download what is called Mini Conda. So Mini Conda is also when you install Mini Conda, you will have Conda, but without any packages pre-installed. So it's a lightweight version to install Conda, Mini Conda. It's a lightweight. If you want to do anything, if you install Anaconda, it comes with scientific package with it, like scikit-learn, like pandas, everything. But now we have what is called Mini Forge. So what is Mini Forge? So Mini Forge is basically also, when you install Mini Forge, it's also like you have a Mini Conda, you have a Conda environment. It works the same thing with Conda, but it's kind of Mini Conda is managed by Anaconda people, but Mini Forge is like community-based maintenance. Some stuff may not be available. Some packages, when you try to install some packages, they may not be available in Conda. Anaconda and Mini Conda, but they can be available in Mini Forge. So sometimes people prefer to use minif. So the basic idea here is just to let us know that we can use two ways. So if you try to install a package using Conda and it is not available in the Anaconda distribution, you can just install it using pip. Yeah. Okay. So managing environment, we already know this. As well, if you want to create, do your machine learning stuff, always create environment so that you will not actually create a separate environment. You will not make your Python space. What do you call it? Python. Yeah, my Python, you cannot mess me with your Python environment. So there are different ways to create environment. Number one, we can use VM, right? And number two, you can use, for people that are using Conda, you can use Conda environment. So you can see Conda create this minus name, and this is the name of the environment, Python machine learning. And now when you create this environment, so you can see for me here, I'm using data science. This is the name of my environment. So for example, I can say Conda deactivate. So when I say Conda deactivate, I'm now in the base of my computer, base on my, but I create an environment called data science where every package I want to install, I want to work in is under the data science stuff. So here I can see Conda create, Conda activate data science. Now I activate. Now, if you want to create a new environment using Conda, this is what you use. Conda create. Now you specify the name of the environment, Python machine learning, for example. And now I can specify the Python version I want to install, Python 3.9. Maybe I want to install also, maybe I can say pandas, right? Something like this. So maybe I want to install maybe which one again? Okay, anyone you want, you can just write them, and now you can press enter. So you can have as many. So for example, in my computer, I can have 1,000 environment. I can create 1,000 environment, right? So environment allows you just to manage projects. So when you create, so you can see here, it tells me, yeah, do you want to install it? I say yes, install. So here is in creating environment for me. As you can see, I really like Conda to manage environment. I don't use virtual M. So this is the owner of the book as well, that you can see the example he gave. I just pull them out. So when it finished creating the environment, now it will create the environment and automatically install what I asked it to install. I asked it to install what that Python and pandas. So now it will install them, and yeah. So let's see. You can see it's doing that. All right, so you can see now it finished creating the environment. So I have now Conda Python machine learning environment. So if I want to activate it, now what I need to do is I can say Conda activate. What is the name of the Python ML? Yeah, so you can see now I am inside my Python ML, right? Now, when I want to use also, if we're using BS code, I can change my environment. You can see here, data set. Now I can select my environment here. Do I have the, yeah, Python ML. Can you see Python ML that we just create? So you can see here, I'm now Python ML, right? So everything now I do installation, pip install, maybe NumPy. Okay, not Conda install NumPy. You remember, okay, remember I did, now I changed the environment, Python ML. Let me restart this. Oh, okay. So you can see here that I changed the environment to Python ML. So if I want to install, for example, Conda inside it, so I can say Conda install NumPy. So when I install NumPy, it will now be installed in this my environment called PyML. So when I install this, so you can see you can separate your machine learning. So already I have my NumPy installed. When I do that, because I try to install pandas and now pandas need NumPy. That is why it install it. So maybe I can say Conda install NLTK. Oh, no. Oh, yeah. So that is basically what is meant by environment management. So I prefer to use Conda. If you are trying to use Conda and the package, sometimes the package you may install in Conda is not available. Then you need to use pip to install it. So that is all about chapter 1. Yeah, any question? Any question? So as I said, this book is like it's gonna be a marathon, right? We have 19 chapters. You see that? So the chapter 2 is training simple machine learning algorithm for classification. Now today we have seen how we can basically do a basic we can set up our machine learning. So what you can need to do before our next session, try to do install scikit-learn and do all the installation you need, create an environment, install Conda if you don't have, and now try to see how you can start doing the examples that we'll see in the next chapter. So the next chapter is training simple machine learning algorithm for classification. That is what we'll see inshallah tomorrow. Any question? Yawa.
Doctor, akwai wacin paper AI and the everything in the whole world wide. Irin kamar ta yi accusing ɗin irin machine learning practitioners. Akan cewa irin abinda suke yawanci irin arbitrarily suke selected ɗin tags da kuma collection of data. Kusan ta yi magana akan kamar wannan example ɗin da ka bamu na Irish ɗin nan da ragowar examples ɗin da wancan littafin da muka yi. Irin ta soke a paper sun soke sosai musamman abin da ya shafi benchmarking a AI and machine learning haka. Take cewa irin kamar irin wannan research din kamar na wannan Irish din babu abin da ya karawa irin kamar field din botany haka. Da dai irin wayannan haka. Irin ya za a yi haka mu a nan gaba irin kamar me avoiding din wannan arbitrary selection of data da kuma collection da watakila features din da irin ya dace ko kuma su problem din da muke kokarin zamu solving a wannan irin area ya kasance problem din ne na gaske ba irin kamar suka soka ba a wannan paper ba dan san me zaka ce ba.
So na gane. So I think the most important thing shine maybe sometimes idan ka ga ba mutane idan suka abu maybe ba expert din field din bane. Misali yanzu aka ce likita yana so ya gano wanda yake da kansa ba kansa ba. So idan likita da ya shekara 10 shekara 5 yana yin aikin likitanci ya san alamomi na kansa. Ka gane abin da ke nufi? Misali za a ce ga kaza indai aka ga wannan kansa ce. Symptoms. Indai aka ga wannan kansa ce, in 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 aka ga wannan. To yanzu idan dakta da ya shekara 10 yana aiki, aka yi aiki da shi, aka yi developing din data set ta identifying cancer. Kaga ai da akwai in-house mutanen da sun san abin. So kaga ba za a yi developing din data set din da take wadda ba daidai ba, wadda take da wrong. So kawai ni solution ne a jini shine involving din what we call practitioners. Yawa, mutanen da suke cikin abin. Ba wai wani shi machine learning engineer ba kai je creating data set yanzu zai machine learning. I involving in practitioners. Ai dole ne a wannan cycle din sai an develop su suka san problem din, su za su gaya maka gwangwan abin da yake ciki. Ka gane abin da yake nufi? Kamar
ina ganewa.
Yes, somebody want to talk. Go on.
Ina ga doctor kamar futures ne ba su musu ba kenan ko maybe.
Maybe
there are some certain things da ya kamata a yi amfani da su ba a ce length and width of the plants.
Ina ga wannan.
Ai ba wannan ba ne, generally suka ɗauka don in aka ɗauka tun daga tarihin benchmarking suka ɗauka. Suka ɗauki abubuwa lafiya tana da abin nan. Akwai wannan application da na nema ne na PhD. To sai suka ce na yi summarizing din ita paper.
Okay, paper
AI and everything in the whole wide web.
Ka turo min man karanta ta.
Kamar na share na ta mana.
Wallahi paper tana da kyau sosai dan wannan paper kam ta yi. Saboda ainihin real life abu ne ya faru a UK. Wani ya so ya yi irin kamar gidan mutan daɗin nan. Amma a ce ya haɗa komai na duniya a ciki. to shi ma haka suka kira shi ma wannan benchmarking.
Okay.
Musamman general abun nan bari sharing din people.
Kai mun sharing sai inganta. So ina ga dai for me ne ina tunanin kamar in dai a curation na irin wannan abin. So for example, example din na bayan na abin nan na likita. So maybe another example shine za mu creating model misali na sentiment analysis. So sai na ɗauki mutane na ɗauko data sai na ba su see annotation data. In fact, kaga in a nutshell ma, no any data that is not biased. Kagani, every data is biased. There is some level of bias in any data, whether a creation data ko kuma a wani abun. That is fact. So for example, like involving the mutane su min annotating data, positive, negative. So sai kasance maybe people sun ce idan za a annotation din nan dole ne a involving them different misali sex, misali a ce da akwai mace da namiji, but idan ka ba maza gaba daya, so za su ce ai da akwai bias a wannan abin, ka gane? There are a lot of ethics there concerning data set creation a duniya da abin nan that it's a big field to talk on. Yeah, so I will read the paper ni ma sai mu ga abin nan insha Allah.
Ga ta nan na turo ta.
Na ganta, na ganta. Okay, good. So anyone with question or contribution? Okay, so in Aga we are good. Maybe we can see tomorrow, inshallah, to continue chapter 2. But as I said, please try to just practice to set up your computer to go through, because this is going to be practice. Yeah. Okay.